So we are now going to go ahead and review the final for Math 6, Semester 1, Quarter 2. First thing to go over is the real number system. So if you take a look at this paper right here, or this page right here, you see that how rational numbers is opposite of irrational numbers. Rational numbers have other little subsets inside them. You start off with the first one, which is natural numbers. Natural number does not have zero. So that's all the positive numbers from 1, 2, and 3 and beyond to like 100 million. The next circle beyond that is going to be whole numbers. Whole numbers is everything that's in natural numbers, but you include zero. You paying attention over there? Yeah. That's the only difference. Whole number has zero. Both whole numbers and natural number do not have any negative numbers. Negative numbers go into integers. So when you're in the integer category, you include all the whole numbers, which is 0, 1, 2, 3, all the way to positive infinity. You include all the natural numbers, which is 1, 2, 3, all the way to positive infinity. And now you have whole negative numbers, like square root of 49 is 7, or -8, or -100. But there's no decimals. And if you have a fraction, the fraction has to equal a whole number. Like 6/3 is an integer because it equals 3. Or -12 divided by 4 is a -3. It's all within integers. When you have decimals and fractions that has decimals, once you reduce them, then you go into rational numbers. Rational numbers are decimals with patterns, like 9.454545. The 4-5 in the tenths and hundredths place, repeat. Or if you have 3/4, 3/4 is equal to 0.75, that decimal stops, right? 2/3 is 0.66 repeating. You have any decimals as long as it's repeating, or -3.4, which stops in the tenths place. These are all rational numbers. Opposite of that is irrational numbers, like pi. It's 3.141569. This actually continues on forever and ever, and there's really no pattern with it. Square root of 2, square root of 3, square root of 10. All of these are decimals with no patterns. So it's best if you just memorize square root of 2, square root of 10, square root of 3. All of these numbers over here will be irrational numbers. If you do have, however, square root of 4, that gives me a 2. That will be a whole number. Square root of 9 is 3. That will give you a whole number. Square root of 1, which is 1. That will be a whole number. So it's a rational number as well. So if you look at this, square root of 1 is 1. Square root of 2 Did you take my calculator? If you go ahead and look it up on the Desmos, it's going to give you 1.41421, which does not actually have any of the patterns with the decimals. And similarly, if you're to do this with square root of 3, notice that you have the same situation. However, with a square root of 4, you get a 2. Then with a square root of 5, you get the same situation. So that's an irrational number. Do you see that? Let's try square root of 6. That's also an irrational number. Square root of 7, a rational number. Square root of 8, a rational number. Square root of 9 gives you a 3. So that is a rational number. It's a whole number. And then square root of 10, which right here is also irrational. So the pattern that we see here is that square root of 2, square root of 3, square root of 4 will give you a 2, which is a whole number. 5, 6, 7, 8, 10. So the ones I'm highlighting right now in yellow, these are always going to be a rational number, like a whole number. The one that I'm highlighting in blue, all of these right here will give you a rational number. Do you see that? All right, so let's take a look at number 1. So number one, what you have here is you have pi. What do you think that's gonna be, Grayson? Yeah, so it'd be under irrational, okay? Irrational. Square root of 15 is not 3. What is the square root of 15? If you're not sure, I'm not sure if you can use a calculator, but it does. It is an irrational number. It's 3.8729. Do you see that? So in this case, this will also be irrational. 5.73, you see where there is a little line right there? That means it's repeating. So what would that be? Yeah, that would be a rational number. What about 0? Specifically, which one would that be in? Yeah, whole number will include 0. She doesn't use natural numbers. She uses counting numbers. That's fine. Counting numbers is the same as natural, so it does not include 0. What about negative 37? What would that be? Which one? Okay. 18. What would that be? No. It'll be counting numbers. It's also a whole number, but we're gonna go ahead and reach the maximum of this. Do you understand? Integers number 37. All right, square root of 8. What do you think that's gonna be? Yeah, we already talked about it, right? Everything that was from square root of 2, 3, 5, 6, 7, 8, 10, and we also determined 12 and 15 are irrational. The only one that is going to be rational is 1, 4, 9, right? That's under 10. So 8 will also be irrational. What about the last one? Yeah. Okay. What other ones do you want to review? Do you want to go over integers? All right, so looking at integers for number 9, it says find that. First thing I notice is that when you have a negative and a negative, you're going to be adding them, but your answer is a negative, so that's negative 18. Order of operations, bring down the negative 3, negative 21 is what you have. Number 10, I hope you don't put a question mark there. It's basically saying a positive 18 minus a 4. What's 18 minus 4? I'm asking you a question. What's 18 minus 4? Okay, number 11, find the difference. Double negative makes it a. So we're going to rewrite it. What is that going to give me? Okay, number 12, which one has the greatest value? Let's find all of them and figure it out. Double negative makes it a positive. So what's 18 plus 5? 18. Okay, negative 12 minus 14. Positive or negative? It's important to go ahead and write that down. Okay, next one. Okay, D. All right, so let's continue with this. So then here, this is going to give you a negative 7. And then what is this one here? Double negative gives you a positive. So what's negative 5 plus 30? What does that give you? No. Negative 5 plus 30. Okay, so which one's the greatest? Greatest value. You always want to make sure you go back to the question to make sure that you're answering the questions correctly. And so this won't be the greatest. What's the second greatest? Third greatest? Last one? Smallest, right? Okay. All right, let's go on. So we're going to move on to the next part, which is number 13. Do you need me to go over number 13 with you? 13, 14, and 15. You sure? Okay, all right. Okay, I want you to take a look at number 14. So take a look at number 14. What do you think your answer is going to be? Is it a positive or a negative? Positive. Why? Why positive? So count the number of negatives. How many negatives do you have?
I have I have 3 negatives.
You have 1, 2, 3, 4. You have 4 negative signs, which is an even number. If it's an even number, your answer is always going to be positive. Do you understand that? On the other hand, if you count and you have, let's say, 5 negative signs, that's odd. So what is your answer going to be?
Negative.
It's going to be a negative. So looking at this right here, which one do you think is going to be the most accurate answer? You know it's positive. Is it positive 10 or positive 30?
Positive 30.
Yeah, because you know that 5 times 2 is 10, right? But then you also have a 3 right here, so it's not going to be 10. It has to be 30, right? All right, let's move on to the next part.
Wait. Yeah.
What do you have a question on there? Okay, number 16. Do you have a question on 16, 17, and 18?
Um,
16 is on division, which I think will probably be fine. But the order of operation is right here, so 17 and 18. Do you have questions on order of operation?
no, you did that last night. So.
Are you sure with absolute values? Let's just quickly go over this one. Okay, so I want you to go ahead and take a look at number 17 and 18. What do you think the answer is? Don't look at your paper, look up there and see if you're able to figure it out by yourself. Just looking at number 17, what do you think the answer is going to be?
22.
Positive or negative? Okay, all right. Number 18, do you think your answer is going to be positive or negative? Just looking at that.
Negative.
Okay, so this is going to give you a negative 27, right? Minus, that 3 is going to become a positive 3, right? So negative 30 is your answer. C, okay? All right, let's take a look at number 19 and 20. Do you need any help with this one? Okay. What about number 21, 22, 23? Order of operation. If you need help, pick one.
But can you repeat that again?
Do you need any help for 21, 22, and 23? Okay. Do you need any help for number 24?
No.
Okay. 25, 26, 27, 28. Or actually, let's go on 25. 25 is on divisibility. Remember that? Okay, so make sure you remember the rules. With 2, digit have to be even 0, 2, 4, 6, 8. Okay, and if your last number has a one of those numbers, in this case it does because it has a 2, right? You know that yes, it's divisible by 2. Divisibility rule for 3. If the sum of the digit of the number is divisible by 3, the number as a whole will be divisible by 3. So you do 1 plus 5 plus 7 plus 3 plus 2. We determine that is going to equal to 18, right? 18 divided by 3, it's a divisibility rule of 3, it's 6, so it's divisible. So the answer is yes. For number 4, the rule of divisibility is if the last 2 digits are divisible by 4, what's the last 2 digits of this big number right here?
2 digits. Please repeat that. I didn't really get.
The last two digit has to be divisible by 4. What's the last two digit of this number? Is 32 divided by 4. Does that give you a whole number? So yes, it's divisible. Divisibility rule 5, the last digit has to be either 0 or 5. What's the last digit here? Is that 0 or 5? So it's not divisible. Number 6, is it even and is divisible by 3? Is this number even? Look at the last number. If the last number is even, it's even. It's a 2. 2 is even, right? 2, 4, 6, 8, 10 are even. Is it divisible by 3? Well, you could just go back to the table and was it divisible by 3? Yeah. So then is it divisible by 6? You got to pass that test, even and divisible by 3. You need to memorize these rules, okay? Number 8, the last 3 digits are divisible by 8. What's the last 3 digits here? The last 3 numbers here.
The last 3 numbers are
7, 3, 2, right? So is 732 divisible by 8? And we did the work right over here. Was it divisible by 8? Because as a remainder, so the answer is no, it's not divisible by 8. For 9, the sum of the digit is divisible by 9. Well, didn't we find the sum of the digit back in number 3 right here? Which is 18. 18 divided by 9, what is it? 2. So the answer is yes. For 10, if the last digit is 0, it's always divisible by 10. What's the last digit?
last digit is 2.
So is it divisible by 0 or 10? No. But if it was 0, it will be fine, right? So that's that. All right, let's take a look at this part right here. 26, 27, 28. Lowest common denominator. Do you need me to go over this with you?
I got this one.
For number 27, you know how to do this in 2 different ways?
Actually, yeah, I do need to go over to this one.
Okay, so let's go back to figuring out what is the definition of the lowest common denominator. All right, so let's go over the definitions. Greatest common factor is the largest number that divides evenly into 2 or more numbers. Lowest common multiple is the smallest positive number that is multiple of 2 or more numbers. So even the name greatest common factor, you think about a large number, it's actually opposite. It's the biggest small number that can divide into 2 numbers, right? If you're dividing something, it's going to be a small number. Least common multiple means multiply, which means it's the biggest number that 2 numbers can multiply and then equal, okay? So in the events of 4 and 6, like let's try to find what is the lowest common multiple and greatest common factor of 4 and 6. Do you see that? So with 4, we're going to do just 2 times 2. Those are prime numbers now, right? You can't go any further than that. With 6, it's 2 times 3, right? So greatest common factors, what do they share? So what do they share in this tree that we did between 4 and 6? Don't they share 2? That's your greatest common factor, okay? If they share like a 2 and a 3 and a 4, you just multiply it together, right? And that'll be the number, correct? Lowest common multiple is different. Greatest common factor is what do they share? They both have, right? Lowest common multiple is not only do they what they share, but you also need to multiply with what they don't share. So you have to include basically everything, okay? So what do they share here? 2, right? But then also, what do they not share? 2, another extra 2, and what else? A 3, right? So you do 2 times 2 times 3, which is then going to give you a 12. Do you see that? Lowest common multiple is always going to end up a bigger number, okay, then greatest common factor. So now that you know this, let's go back to over here. Let's try this, okay? Let's do the factor tree for 18. Let's do it for 30. Did you do the factor tree on your paper yet?
Yeah.
Okay, so with 18, what times what gives me 18? Give me two numbers. Any two numbers.
Wait, this is like how to do noise coming multiple.
I'm not asking you again, what are the ways of you finding this? What times what equals 18?
Times 3.
Good, that's a prime number. Now what times what gives me 6? So for 18, 3 times 3 times 2. Do you see that? Now let's focus on 30. What times what gives me 30?
3 and 10.
Okay, 3 is a is a prime number. What times what gives me 10?
5.
Okay, lowest common multiple means you have to include everything, right? So let's take a look at this. It doesn't ask you for the greatest common factor. Greatest common factor is what they share. What do they share? Between 18 and 30 in the tree. What do they share? 3. So greatest common factor, it doesn't ask you that, but it will be 3. So it's gonna be 3. And then what do they not share?
5.
A 5. What else? Oh, you know what? No, greatest common factor is not just 3. They share a 3, but what else do they share? A 2. So your greatest common factor is gonna be 3 times 2, which is 6. That's your greatest common factor, okay? What else do they share? Or what else do they not share? 3, and then what else? And a 5. So 3 times 5. So your lowest common multiple is gonna be 30 times 3, which is 90. Do you see how that's a very big number? Let's find the greatest common factor of 42 and 90, okay? And she said do this in 2 different ways. This is one way. What's another way that you can find this?
5 common factor, list the common factor both.
Yeah, 18 and then 30, right? So this is the second way. So this is the first way. Here is the second way. So then we have 1, 2, 3, 4, 5, 6. But do you see how this way, it's going to take you a very long time because the number is 30 or 90, right? So let's see how far we can go. 18 times 1 is 18, 36, what else? 54. What's on your table, Grayson? 72, 90, and then just for kicks and giggles, let's just do one more. 108, right? Then let's take a look at 30. 30 times 1 is 30. 30 times 2 is? Keep going.
30 times 3 is 90.
Okay, so looking at this, which number do they share? 90, right there. Do you see that? So your lowest common multiple is 90. Now let's take a look at number 28. You ready? Are you ready? For number 28, we're going to do the factorization, and they do it in 2 different ways, right? So let's do the first way with the tree, right? So 42 and then 90. So let's break it down. What times what gives me 42? I could do 6 and a 7, right? 2 and a 3. These are prime factorizations. 90, I could do 3 and 30, 3 and 10, 2 and 5, right? What is the greatest common factor? What do they share? 1, 3, and
We both share 3 and 2.
good. That's the first way. Now, what is a second way of finding the greatest common factor? What can you do?
I don't know.
So the first way that we have is a tree prime factorization, right? That's the first method. Second method is going to be with a list, okay? So we're going to have 42 and 90. You're going to do the list from tree. Okay, so you're not going to do 42 times 1, 42 times 2, like we did with this one. Do you see how this one you have a 1, 2, 3, 4, 5, 6 right here? You only do this for lowest common multiple, okay? So for the list method, for greatest common factor, you're going to list all the numbers from the tree, okay? So let's list the numbers from the tree. So for number 42, from your tree, do you see how you had a 2, a 3, and a 7? Do you see that? For 90, you had a 2, and I'm ordering from smallest to biggest, and a 5, right? So then from here, do you see how they have these two that are the same number that they share? So then what you do with that is you just do 2 times 3, which is 6. Do you see that? So those are the two different ways of finding that, okay? All right, for number 29, 30, and 31 are fractions. So what I'm going to recommend that you do is you go ahead and review this between 29 all the way until 48, which is the last part of your test, right? And I want you to highlight and circle all the ones that you don't know how to do, and I'll come back and we'll go over this.